Hey guys, now this session let's talk about property connected to chords in circle. Before that, let's just go ahead and talk about what are equal chords. So for that, I'm just taking a divider here. And I can see a diagram in this case, and I have this line and this line, where we call them as chords because it is cutting the circle at 2 points and is not passing through the center, so that becomes a chord. So let me name this guy as A and this guy as B and this guy as P and Q. Right, so these are my two chords. So are they equal in length? Now let's check. How do we measure the equal in length? We'll just take a divider and try to get the distance of this guy. Okay, that is the distance I have exactly. All right. So let's check whether this distance is same as that guy. Look at that. Yes, so it works. So I can say that the chord AB is congruent to the chord PQ. So if I have to write that, I just need to write that chord AB. Right, the chord AB is congruent to the chord PQ. Right, that's it. Very simple. So we have another chord here. Another two chords basically. Let me name them as L, M, and P. Now P is already there, so let me take it as X and Y. Okay, so let's check whether these two guys are equal or not, or congruent or not. So what you have to do is just measure one of the guys using a set square or a divider basically. Yeah, that is it. So that is the length. Look at that. So that is the length that is equal in fact, right? Yes. Look at that. Yes. So is this also the same size? Yes. Exactly. I can see that. Right. So I can just write that the chord, I can write the chord LM is congruent to the chord XY. That's what it means by equal chords. Come back to this guy. So what is the property all about? If I know that two chords are equal and I know how to measure that, right? So just use the divider and just try to get this length of this guy. Look at this. So that is the length of the chord AB, right? So I just have to show it like that. So that is the length of the chord AB. Look at that. Right, perfect. Right, and I can see the length of the chord PQ is also the same. Right? Yes, it is the same. Perfect. So now I am very sure that these two chords are same, right? Equal length. So what I'm doing now is from the center of the circle, I'm drawing a perpendicular ON to this chord PQ, which is equal to the chord AB, or I can say congruent, and I'm drawing another perpendicular from O only to the chord AB. So I have two lines now. That is called the perpendicular distance from the center to the first chord, and that is a perpendicular distance from the center to the second chord. Now how are these two distances? Are they also equal length? Let's check. So I'm just measuring it from here. Look at that. That is the length from the origin to the big chord PQ. That is the length. So let me just check it the same. Yeah, exactly. Right? It is exactly the same. So I understood one thing. If I have two chords which are of equal length, then if I draw perpendiculars from origin to the first chord and perpendicular from the origin to the second chord, these two perpendicular lengths are also congruent. So I just know that ON here is congruent to OM. Right, that's all about it. Okay, that's a perpendicular distance. So let's frame it out in a statement. It says congruent chords. These two guys are congruent chords. I know that. In the same circle, are at an equal distance. It means this is the distance right from the center. That is all about it. That's the second property. So let's work more problems based on this.